Check. No.
Yes.
You were checking, right?
No, I wasn't. Yes. And you have to see always with the two microphones. So this is for the remote audience. The other one is for the audience inside, if there is audience. And also, when the questions are, you have to repeat the question of the person who asks, so that the remote audience also gets it. That's all. I will go to room one. I think he was checking that one, right? The mic.
Okay, he was checking. Just connected to the speaker. Okay.
Your session was postponed.
Yeah, that's right.
That's why these people are not informed about that.
Yeah, they have updated the website name, but yeah, remote
I
folks
think
can.
most of the people haven't checked it.
Yeah. The sessions usually start at 11 only.
Yeah.
So they start coming at 11.
Uh,
And I think like from this remote, like there's no audience there.
remote audience.
YouTube live, right?
I think it is going live in YouTube.
Yeah.
Yeah.
There's
So,
not much audience there.
it's okay. Yeah.
Can you see like how many people are watching live?
I think it shows me here only.
Mm.
Yesterday it was shown.
I think someone.
We have to join from another laptop and then see how many people are live. Check. हाँ. 11 इसके साथ. ठीक है ना?
Hello. Guys, the session will start from 11 a.m. sharp. If you guys want to call your friends, just tell it to them, okay?
Actually, it was updated in the website, but since most of the people might checked it earlier only, they haven't. Wasn't it updated? We were informed that it has been updated on the website. Actually, this session was supposed to be yesterday, but it is postponed. Right. Exactly. हाँ वेबसाइट पे अपडेट है हाँ एक ही
Yeah.
Yeah. Yes. 11:25. The next session will start from 11:25. Wait, let me check. Let me just confirm it again.
Yeah, 11:25.
11:25. Yeah. Yeah. 11. No. हाँ 11:25 only. Yeah. 11:20. Yes, I guess. I think we have to extend it, but yes, speaker. Hmm. Let me. Yeah, yeah. Let me just confirm it to the heads. Ah, right, right, exactly. Ritika से पूछो. Yeah. साढ़े 10 मिनट हो गए. Okay, fine. We can extend it to 10 minutes.
Yeah. We can start the live recording again because it will get recording there, right? So it should start from that point only, right? Otherwise, this will be useless for the
Yeah.
like, when they reference it.
I mean, when it will be recorded and uploaded, this part will be cut.
So this will, because it's live, I guess. We have gone live, right? This will be recorded. They have to again start the
Right.
live.
So,
Actually, when it's live, it's okay. But when the streamer stop, we'll cut the first. Because
So you just cut that one and then start.
yeah, from the recording will be from cut.
You have
we
to
remove the
upload the
unnecessary
recording. Live sessions cannot be reference information, right? They'll be stored on the
Live will be there. Till the live will be recorded by YouTube itself,
Okay.
but then it has a functionality where
Okay,
it
okay. When
allows
you
you
just
to
it will be available in your channel.
it will be available on Canonical server.
Ravi,
अच्छा एक और चाहिए ऑडियंस में. हाँ वो बोल रहे
There have two mics.
हाँ they have to.
and एक और.
अरे वो
उसके लिए
You have to announce, right? You can announce it from here. No?
No, I mean we need one for the audience.
Audience, right? That we can ask him then.
Hello. Hello.
भैया माइक होगा.
Hello.
है वहाँ पे.
हर्ष है बोलिए.
वो लेके.
हेलो. हेलो. नरेश अभी आए बोलिए. माइक आ गया ना.
इसका यूज नहीं है ना सर. कोडिंग का यूज नहीं है.
हाँ कर दिया.
सर थोड़ा सा
ठीक. इसे ओपन रखें ना, यहाँ पे रखना पड़ेगा.
ऐसे रखिए. अरे यार
स्क्रीन.
अभी आप सपोर्ट नहीं लगाए ना. लगा सेकंड.
यहाँ ये वाला शायद यहाँ लगेगा.
So this is for a demonstration and that is for
Support को नहीं. Switching.
क्या था एक बार.
चल तो रहा था.
नहीं ये
दोबारा लगा.
किया था मैंने.
Put to slot 2.
उसको सब एक इधर लगाएगी.
क्या ये तो
चलो ऐसे ही रखो ना. फोन उठाओ किसका गिर
पैड रखे थे ना. उनका स्क्रैच आ जाएगा.
उसको पैड ना रख. इसको
इसीलिए मैंने इसको मैंने किया था कि आप इस पे पैड रखेंगे. पैड में दिक्कत है तो हमारा
नहीं पैड नहीं चाहिए. मेरे को चाहिए पैड.
ये देखिए यहाँ से दिक्कत कर सकता है ना, अभी इसे रखा गया था ना,
It's not working.
इसलिए मैंने इसको डाउन किया।
It was working, but
उसके पीछे को ऐसे पेपर लगा के रख देते हैं स्कूल का।
हाँ पेपर लगा दीजिए ज़्यादा बेटर पड़ेगा, क्योंकि हम इस पे रखने नहीं दे सकते, पेन वगैरह भी काम करना पड़ता है।
पेज रख लो, पेज रख लो, इसको निकाल दो पीछे वाले उसको।
कोई बात नहीं,
चल रहा है क्या करती है?
ऐसे रख दीजिए,
ऊपर रखो
कोई
इसको, इसको ऊपर रखो।
रखा है ऊपर पूरा नहीं आता, इसलिए ऊपर से डाउन कर देंगे।
ये स्क्रीन को देख लेना।
स्क्रीन
स्क्रीन में
इसका देखो पर इसका देखो नहीं हो जाएगा, नहीं होगा तब भी चल जाएगा।
अभी लॉन्ग को रखो। चल रहा है यार, बढ़िया है।
खुला है नीचे,
खुला है। नीचे खुला है, चाबी उसी में लगी, नीचे लगी है। उनका दोबारा देखने
देख लो एक बार ऊपर से।
उनका वाईफाई नहीं है।
हाँ ठीक।
ऑडियंस से बोल दो कि बेटर रहेगा अगर आप सजेशन करना तो।
इनपुट सोर्स तो नहीं चेंज करना होता इसमें।
नहीं
Yeah, it was there, I guess. I think 392.
तो वो तो देख रहे हैं वहाँ पे पोडियम आया था।
नहीं चल रहा है।
अरे ये तो नहीं होगा तब भी चल जाएगा।
प्रोजेक्टर मतलब क्यों काम नहीं कर रहा? सब किसी भी काम नहीं कर रहा।
अभी चल रहा था।
हाँ अभी चल रहा था, फिर ये ऑफ
चल रहा
किया
था।
मैं अगर किसी और भी चल रहा हो तो चेक कर लो, मतलब
वो तो चला देंगे, वो तो चल जाएगा
फिर
दूसरे तरीके।
तो पहले ये करो ना, हुआ कि दिक्कत क्या हुई थी?
विकास को कॉल करना,
मैं विकास नहीं करेंगे,
एक बार इसका दिक्कत हुआ तो
कुछ नहीं दिक्कत।
डाउन होने का।
इसको कनेक्ट करो पहले।
ये तो ये
हाँ अभी
स्टार्ट हो चुका
स्टार्ट हो
सब कुछ
चुका
सेटअप अभी अभी मुझे पता नहीं कैसे हुआ हुआ कैसे हुआ।
सब सिस्टम तुमने
हाँ ठीक है,
चल गया।
ये चला अभी तो
हाँ
ये तो
वो चला।
प्रोजेक्टर। तो उसको चला भैया, उसको चला दे। किसको? नहीं इसको थोड़ी चलाना है, इसको
चलाना
तो यहाँ से सेव हो रहा है। अच्छा
वो नहीं है, इसमें कुछ कंट्रोल नहीं।
मास्टर में आप
क्या पोडियम थोड़ी मेरा डाल दी, एक पे डाल दी।
नहीं पोडियम चलो करो, हाँ पोडियम डालो।
हाँ किया उसको बस शेयर।
हाँ चल रहा था, क्या कलाकारी कर रहा
नहीं भाई मैं तो ऐसे ही था।
ऐसे ही कैसे था यार, बराबर चल रहा है।
चल रहा था।
पूरा सिस्टम जोड़ के तुम पता
एक बार
नहीं
विकास तो करो, जहाँ पता चलेगा उस वहाँ भी तो ये तो आ तो गए।
शायद डाले हो।
ये तो ठीक है, पोडियम चला रहे हैं।
पोडियम चला रहे हैं ना।
ये तो अप डाउन के लिए एक बार विकास के फोन करो। क्या है अरे उससे दिखा हाँ भी सही है लेकर इससे कोई दिक्कत नहीं इन्होंने पैड रखा था तो हमने कहा इसको ऑफ कर देते हैं इससे दिक्कत ना आ जाए बस इतना ही तो किया
There's not an auto lock. An auto
यहाँ पर हुआ
lock,
था हमने
and
ठीक किया
then when a screensaver
रात को
kicks
फोन
in,
किया था
the person
अपन
with the
कहाँ से किया था
password
वहीं से फिर से कर दो
is
क्या देते
far
उसको
away.
फोन करने का है ना दाब के रखे
What is the problem here?
Yeah, the projector is not working, so now it's working.
Hello? The room 2 is empty.
दबा के
There
रखे
are perhaps 10 people. So it is not, it seems that if you want to have a good slot on a conference, you should not have the first one.
It's the morning one.
So I don't know what one has to put into the first slot as a conference
नहीं
organizer,
नहीं इनको सिलेक्ट करो पूरा बंद करो
because
ऐसे रहने दे
it's the
बंद करो
first slot.
बंद करो तो जान दे
Yes. Don't forget to start
ये चीज का फिर
the
कैसे खुली रहेगी
good luck.
इसको यहाँ से डालें हाँ तो ऊपर से डाल दे
So, till the projection from will be from this laptop only.
What?
Project from this.
Ah. So the projection. So this, I have seen this projecting. What was wrong with it?
Yeah, I don't know. It was just got blank. From the screen.
The projector. The projector
Yeah.
was going into its blank screen, but was receiving the signal of the
Yeah.
laptop.
It's सही था.
सही है भैया चल रहा है
हाँ,
ओके क्लियर है
एक बार टेस्ट कर लो थोड़ा.
हाँ बिल्कुल टेस्ट कर रहा हूँ
It's streaming live now.
Yes. We must check. We must start the stream if we cannot do so yet.
I can just check if it's streaming now.
Hello. Yes. Yes. I can. Yes. I will come. I will only
yeah,
kick
pointer,
off
pointer.
and then I come.
Aryan,
Yeah, pointer.
Aryan.
नहीं अभी वो सही था
Yeah. Pointer.
We are live. We are live. The live streaming has started here. We are live.
Okay.
So we can start the talk here.
Yeah. The pointer.
We will start.
Yes. I have to go to room 1 now because room 1 is an open printing session. And I think I should not.
स्टार्ट हो रहा है और 2 मिनट में स्टार्ट हो रहा है.
I take, yes,
पहले
I
चल रहा
take.
था 2 मिनट में स्टार्ट होगा.
Oi, start.
15 मिनट.
Start.
एक सेकंड
Everything is 15 minutes detail. Start.
पॉइंटर ला रहे हैं बाहर से लेके नहीं वो ला रहे हैं. ठीक है.
Observe.
Start.
इसका काम है चेक करो.
स्टार्ट कर.
Hello, mic check. So, good morning, everyone. I hope you all are having a great day. My name is Kanish, and I'm honored to be your host for the upcoming sessions. Thank you all for joining us, and I'm sure it will be both insightful and inspiring for everyone out here. Now, it's my great pleasure to introduce our esteemed speaker for today, Mr. Paritoshik Paul, a passionate Drupal enthusiast and free-minded person who loves nature, tradition, and culture, would like to indulge in the social activities to promote the community, motivated from the experience gained, and keeps a motivating spirit in the team while achieving respective goals. A quick learner and receptive enough to adapt new trends. Always keep responsibilities to the utmost priority and well organized. Loves adventures and daring sports. Sense of music, most importantly, to enjoy the rhythm of life. So, without further ado, let's welcome Mr. Paritoshik Paul on stage. Please join me in giving him a warm round of applause, everyone.
Thank you very much. Hi everyone, good morning. So before I jump into the session, I just would like to know who all know open source. Just raise your hands. Open source, yeah. You do know about open source, right? What is open source is? Okay. I think I assume everyone knows about open source. So that's great. Then How many people contribute back to contribute back? Nice. Okay, quite a few. Now, who knows Drupal? Yeah, okay. Two hands, okay. Okay, nice. So, good to know that most of us do not know about Drupal because it's the session's agenda, right? So, it's from no wise to nature, right? So, so now when you know Drupal, then just switch to the next slide. Okay. So I'll introduce myself as well. I know about you guys now, right? So scan this code, right? I I'm known from an alias of the Drupal created in Drupal community. Okay. So that's my profile name on Drupal.org. So if you scan this code, it will land you to my Drupal.org profile. My name is Pallavi Paul. I am a GSOC ex-GSOC mentor, technical architect, trainer, and ex-speaker.
And that's going to happen with like most like projects that are quite sizable. You wouldn't understand the first of it, but you still have to get your work done, right? So what you do is you need to get an idea from a very high level how it works. You need to get an idea of the overview, flow of it, but then you don't really need to learn every single part. And I think that really happens because when you really work professionally, you're working on big software, and there are also other people working together with you, right? So the things get modified. You cannot possibly learn everything. You cannot possibly have idea for everything. So that's the takeaway. And okay, now it's time for the third part and beyond. Okay, so these are going to be my experiences that are on top of the Google Summer Code experience. So after Google Summer Code completed, I think I was having a meeting with Google maintenance a month or two later. So this was time for some reflection. I had been using when working on the music blocks, the source code for like 4.5 months at that point. Uh, well, I had some complaints, right? So again, like this thing happens, and this thing is something that we must anticipate. Okay, so it's like the law of thermodynamics. Entropy always increases. So in any project, tech debt piles up with that. So this is inevitable, and we sort of need regular maintenance. Otherwise, things will go out of control, and at some point, well, it won't be feasible to do anything on that. So that's sort of what I was, thinking about. So these are bigger issues. These are not issues like a button isn't working or something isn't showing up. These are issues like these are more foundational issues. But then before I talk about these issues, let me actually give you a bit of history of the project, the music box project, because I think when there is tech debt, there is a very good reason why that is. So it's important to respect the reasons. So music box was started in 2016. Remember I just told that when I discovered music box was written in Canada. Okay. So music box actually was built on top of another project called Vertical Upstairs. So that project was started in 2013. That was the time when if you have to build web applications, the setup wasn't quite there. You had to do you have to take some very tricky workarounds to do things which we kind of take for granted. Tooling like the Node.js tooling that we have, things like testing libraries like Jest, Webpack, these pretty much didn't exist, but they were in the early years. Front-end frameworks like React and Angular, they were also in their very infant years. So, and also like the big thing, the JavaScript language itself. If some of you know JavaScript, you know that in 2015, ES6 specification was released. So JavaScript is a very different beast before ES6 and a very different beast after ES6. Okay, so these were the technical limitations that kind of forced music blocks to be the way it was. Okay, so like there were objects in the global space, it was sort of a monolith. It was very hard to kind of get work done. You didn't have any sort of tool. You couldn't have niceties like SAS or TypeScript because that would require pre-processing. I mean, actually, you could have those things, but then it would be pretty tricky to like implement that, right? So I sort of proposed that let's like we have learned a lot over the years, so let's rebuild this thing from scratch. So that was thing that didn't work out. So this is around the time. This is late 2020, early 2021. This was when I was finishing college and about to go work professionally. Right? I didn't have the experience. Again, it was a skill issue for me. So what really ended up happening is like we sort of figured out that there are these foundational pieces that we want to do differently. So the way we would do what I would do is that I would really start with the code. This is a very big project, and I'm trying to start with the code. So there is a lot of cognitive overload. And when I'm starting with the code, I'm thinking like how this thing fits in the grand scheme of things. And like I used to get overloaded, and I couldn't get it done. So what would happen is that I would start with a piece of code, I would write a bunch of code, I would work on it for a few weeks, and then I realized that I think of something. So I would like scrap all of that and like start fresh. So I kind of used to give up in the middle and I sort of repeated this process many times. So this was not, getting done. So the thing is, you need to like, okay. So this was the part that I was missing. Well, I sort of learned about the process in the last 1 year or so, from my work experience. Because, well, at work, when I joined, it was a small company. And over the last 3.5 years, well, the company has grown, right? So we do things in a more predictable, in a more controlled manner. So then we have these processes. Now, this is a process, this is not the process, there can be multiple processes. So, well, before I talk, I'm gonna tell you, I'm gonna know two people. One is in the maintainer, original maintainer, Lily Cox, my mentor, Walter. So he tells, like he says, perfection is the enemy of the good. That was happening to me. I was trying to write code, everything that fits together, it required a lot of foresight. It's impractical to have that kind of foresight. Right? So that's why I don't think it's sometimes. And the other thing is, again, this is something my manager at work tells me and on the rest. So he says there are several ways to do something correctly. And then there are countlessly many more ways to do something the wrong way. And you learn that by experience. You learn what works and what doesn't work. So let's talk about the process. So I was starting with the implementation, the code, right? But well, in this process, you don't start with the implementation. You start with the requirements. You're going to build this project, you deal with the what of it. What the design is going to look like, what features are going to be there, what functions are going to be supported, all that. So this thing is usually put together in a document called, I think, there are several names, like functional specification, functional requirements, software requirements specification, product requirements specification. So you do that. Okay. So what happens is like when you do that, then two things happen. So you can have a 30,000 feet view of the entire project. You can see all the different units that are in that project. You should realize that most of these units are sort of independent of each other. So they can be built in a very isolated way. But then they're not really independent. Okay. They do have some intercommunication with each other. So well, you need to have these contracts. You can see all the different units your project has. Some units are bigger, some units are smaller, some units have other units, these are made up of smaller units, okay? Once you have that view, that for each unit, you sort of have a contract. These are going to be the inputs, these are going to be the outputs. And then you can just sort of build these different pieces independently, okay? But then you can put it into a diagram. I think it's called a data flow diagram. And once you do that, well, let's talk about step three. You build this other document. This one deals with the how of your project. So this is called the technical specification. It deals with everything that's in the project about how you're going to actually use it. So all the different data structures, the different algorithms, what technology is going to be used, what different states the software is going to be, all that stuff. Everything except the code. Okay. So you have the requirements, you have the technical implementation, and then you have the actual implementation, which is code. So when you're going to write the code, you're not thinking about how this fits with the grand scheme of things. You only think about what the individual piece is going to be like, and you already have the specification for that, right? You already know that this thing behaves in certain ways. So you can actually write the test beforehand, and then when you flush it out, when you write the code for that, again, you already know what code to write. You already know how to write it, what it needs to do, right? So that way you sort of let's all of this together. So again, you're not starting with the implementation. You start with the requirements and then move towards the implementation. And let's just take one more minute to say this that these documents that I'm talking about, the requirements and the technical specifications, these are not static documents, they change. Requirements change when implementation goes up. Okay? So well, but then you have a whole, very, very high level view of the entire project. You can see all the different things. So if a change is supposed to be made in some area, you know which parts are going to get affected, which parts are not going to get affected, right? So you don't have to scrap the entire thing to implement a change. You only change the features that need to be changed, right? So this is the process that I think I was facing. I have seen this process work. I have seen, from my experience what works and what doesn't work. The more you see code written by other people, the more you learn these things. Okay. So yeah, that's like the biggest takeaway is that we learn sort of learn things from experience. And like I said, the takeaway here is start with the requirements, then you get towards the implementation. But more importantly, don't think in code, think in terms of logic. Because I think this is a mistake most people make. Yeah, and that sort of brings me to the end of this talk. I think I shared a few takeaways that might be helpful to some of you. So yeah, I guess we have a couple minutes left, so maybe if you have any questions, I'm opening up right. Any questions, anyone?
Yes, guys, if you have any questions, please raise your hands and we'll get the microphone to you.
No questions, then let's do everything.
Okay, guys.
Okay, thank you for listening.
So, please give your huge round of applause to the guys. Thank you. Audience is already
Open here.
Okay, guys. So now it's my great pleasure to introduce our esteemed speaker for today, Mr. Santosh Saptarishi. Mr. Santosh is driven by curiosity and fascination for potential of technologies that transform our lives, focused on the telecom service provider domain for more than 2 decades. At present, working at Nutcracker Technologies with application security being current area of interest. So, without further ado, let's welcome Mr. Santosh Saptarishi on stage. Please join me in giving him a huge round of applause.
Okay, thank you. So let me start initially by asking the question: how many of you really understand the word open and how does it? Have you anyone used it? Do you think you have used it? Raise your hand if you know. Okay, thank you. Not many. Anyway, RAM is part of our mobile network that we use on a daily basis, and Open RAM is a type of architecture, so we'll talk about that. So quickly about me, been working in telecommunication service space for more than 2 decades, and I worked in the software-defined network function virtualization space for a short stint. And at present, my interest or my current assignment is in the application security domain. And I've been exploring 5G and related themes on my own for quite some time. And just a quick disclaimer that whatever I'm sharing today is more of a personal endeavor. Whatever I speak, the information obviously is all available in public domain, but doesn't really reflect the opinion or endorsement from my employer at this agency. With that out, let's move on. Next. So this is what I want to cover today, right? If you go to a very big mall, you may get lost. So mobile technologies are like that. And if you try and do a Google search today for Open RAN, you will end up something like that mall. So what I want to do here is just show you a map, describe all the blocks, different technologies. That's why I'm calling it as overview, and tell you exactly where you are, what kind of parts that you would need, and you can contribute using open source projects or even otherwise. Right? So yeah, that's what I want to do. Next, please. So what we'll cover today, right? So we'll quickly look at what is RAN, why we're talking about open RAN, some definition standards, layers around the open RAN part, challenges and opportunities. Challenges, obviously, they make opportunities in themselves. And then some of the enabling technologies. I think some of you who are very interested in this topic would to be willing to look into these further. And we'll take a look at the open source projects. There's some exciting things that are happening in this space. And then a very quick brief summary of the market dynamics. There are some interesting things that we will see here. Next, please. So here is a picture that is going to show you.
I got mine as well.
Okay, so okay, so this is where we start the mobile network, right? So please just pay some attention here. So if you see, we have this radio access network is a part of the mobile network, overall the cellular access network, and then you have the core network, and then there is a backbone, and then then there are the public cloud providers. So when you are accessing an application on your mobile phone, say something like YouTube or let's say OneDrive, where you are storing your files, what is happening is when you are doing this on your mobile, your mobile is connected to the towers, then from that you go on the backhaul network, and then from there it is going to mobile phone. The mobile phone has some special box called packet gateway, and then that is connected to the internet. And then it will connect to the cloud service provider where your application is hosted. So most of our time we are using our phones for apps, right? So that's why here we are calling this as a cellular access network. We are using the entire cellular network to access apps that are somewhere on the internet. Just keep that in mind, it will be relevant for our further discussion. Yeah. Next. So here I'm just trying to describe why RAN is so significant, right? It's one of the most complex pieces of technology that you can come across. It has evolved over a number of years, more than 25 years actually. You might be doing generations of mobile, right? Generation 1, 2, 3, we are in 5G and looking forward to 6G. So the kind of complexity that RAN itself deals with, the radio access network deals with, these are the challenges. It has to do a lot of signal processing, the scale, right? The number of users, the geographical scale, then environmental challenges. The towers and the antennas, they are like out open in the environment. The temperatures can go below zero freezing and anywhere like 50 degrees in some regions. Then it has to integrate. There are some advanced technologies, and then at the same time, it has to be energy efficient also. Because when we're talking about cellular phone network, like for example, if you take a typical operator in India, they will have anywhere between 150 or 200,000 towers and then equipment of that. So huge investment, huge ongoing cost. Right? Next. So what was the story of RAN so far? Right? We have been 5G, but how RAN was structured today and what is changing right now that leads us to talk about this topic today. So RAN basically, as I mentioned, consumes major chunk of capex, the capital expenditure, the investment, and then ongoing expenditure, the OPEX for the mobile network operators. And so far, the RAN market has been dominated by three main industry players: Nokia, Ericsson being the biggest, and then Huawei. As some of you would know, Huawei, for whatever reason, has been kind of sidelined due to geopolitical issues and regulation and so on. But still, they are really the dominant players in the market. And this RAN products, because of the complexity that I mentioned, have been pretty monolithic, meaning you buy the entire kit from one particular vendor. So that means what that results into is kind of yeah, it results into multiple issues. So vendor locking and other risk like a service provider cannot really decide how fast they can get new features. They have to depend on the provider and they have low feature velocity, and then the service provider will not have control over that. And very less scope of innovation. So these are the issues that are plaguing the existing monolithic radio access networks. So that is where this open RAN architecture comes to help because of some of the technical advances, the cloud-related technologies are making it possible. So we have, unlike classical RAN, we now have this hardware and software desegregation. Meaning things that were possible only in custom hardware, like a switch fabric and things like that. Some of those things, or many of those things, can actually do general purpose hardware with software that the company has, right? So most network functions can be moved to software. So they will be either virtualized as VMs, but increasingly they will be containerized into something like a Docker or Kubernetes container, and then it can be run on cheaper general purpose hardware. Cloud. So this softwareization is basically driving this revolution, and then it allows the scalability, flexibility, and speed for service changes. Next is functional desegregation. So until 4G, everything in the RAN was plugged together in a single box or something like that, and now with 5G, things are basically being distributed into different boxes. Things that can be easily run on general purpose hardware are being separated out from things that are requiring dedicated hardware like the radio related hardware. And then we have like better control over the number of vendors and ensuring price competitiveness for the service providers. And at the same time, because we are talking about new services in 5G, the kind of energy efficiency that is required, it's very much a need that we make the RAN intelligent in the sense use latest machine learning and AI capabilities to optimize the energy usage and network performance optimization. So that is another thing that can be injected because now the RAN has been opened up. It's open RAN. Right? So these are the three main things: hardware, software desegregation, functional desegregation, and intelligence. These are the contributions, you can say, this is something that's going to be made possible by the open RAN architecture. Next. And why now, right? So far in 4G, the applications were like really limited. The use cases that we were dealing with, like it was really about the bandwidth. High-speed network connection, you could watch media, at the most you can have your video calls. 4G was sufficient. But now, even if you're getting high speeds, the people like you and me, right, who are consumers with a mobile phone, we are not going to be paying very large amount of money just to get even higher speed, which we may not even notice. Phone is probably good enough for us to watch HD videos or play games on our mobiles. But then there are additional new applications that 5G has envisaged, and that involves low latency application. So what is the difference between latency and bandwidth? Bandwidth just says that okay, high speed, it's the amount of data that you are going to get in a given span of time is very high. But latency means that for particular use case, the amount of time that has taken for your data to do the entire click. So when you are accessing an application, remember our first diagram I talked about, right? The public provider A. So the time it takes for traffic from mobile to reach there and come back is fairly long. So that is where the arrival of edge is there. So application has to live closer to the users. Especially there are industrial applications like IoT, Internet of Things, and Industry 4.0, where there is a lot of automation with connected devices. For them, the application cannot live on a distant cloud like Google or Azure. It has to stay closer. So if you take the example of India, Google has only one or two regions, I think Mumbai and maybe Chennai, or maybe only one region. Now, if we want to have a factory and with an IoT and automation in Kanpur, the application from Google will be hosted in somewhere in Mumbai, and the data will have to travel up to that point and then come back. Not efficient, cannot really work with latency, which require latency requirements in less than like second and so on. So that would mean that we need to post those applications closer to Kanpur, maybe Lucknow at most, something like that. And so that is where we have to deploy applications on edge, and that requires cellular open RAM. Meaning there will be so this is where basically the small fragments of cloud or cloud edge or distributed cloud or edge, different names that are used is there, and that is another motivation for going to open RAM. I will give a link that talks about a real life example from the operator. Covers some of these interesting stories. Yeah. There's a lot of confusion if you do a Google search on OpenRAN, so I want to clear that, right? Because these are not some of the same things. So what is OpenRAN and what it isn't, right? So it is not the name of a product or a project. It's not the name of a standard. OpenRAN in itself is not a standard. It does not imply that everything that you see in OpenRAN will be open source. A closed source product also can be part of OpenRAN ecosystem, as long as it is complying with the OpenRAN standard reference architecture and the interfaces that it has defined. Right? And it's not the 3GPP standard. What is 3GPP? 3GPP is the standard defining body for 5G. ORAN is not defined by that. And OpenRAN is not same as ORAN or OpenRAN, these words, right? These words actually mean some specific things. So we'll see what those words mean in different contexts. But if you come, anyone can say that our product is an open RAN, you ask certain questions and only then believe that the company or person. So what it is a new architecture for RAN. It is driven by standard specification, especially by an alliance called ORAN Alliance. We'll take a look at the and then the open RAN itself or the ORAN itself is compliant with GPP. That is a basic condition. You cannot really, there's no option for that. Yeah? So these are some of the industry consortiums that are shaping Open RAN evolution. I would say ORAN Alliance is the major, which is basically the telecom operators alliance from Europe, and now it's almost 1,600 companies have joined this, so there's a lot of force in that, and they have aligned themselves with the Linux Foundation also. So a lot of projects that are started by ORAN Alliance originally have now been made the Linux Foundation project. You'll see that in a bit. And ORAN has been around for quite some time. It has done some wonderful work in accommodating and advancing the network technologies, including software-defined network related projects. So they have these open source projects. So that is their major focus area. So these three are very important alliances that you should keep an eye out if you are interested in this topic. These are additional alliances. 3GPP obviously it's a 5G defining standards body, so they have a stake in that, but will not be looking at these. These two are telecom infrastructure project was something that was started by Facebook somehow. You might be surprised to know that. But they have some work going on. They have a group called Open RAN with no space in between. And then this Open Air Interface Software Alliance is something new. They are from France, and they are trying to build the entire 5G stack in open source manner. So if you are really open source enthusiast, you should be taking these things out. Okay, so quick summary of all Alliance activities, right? There are a bunch of work groups that they have created to organize their work. But main contribution that we have defined the reference architecture on top of the 3GPP, have added few extra nodes on top of 3GPP to achieve certain improvements. So we'll see there after some time, and then right. So they provide things like since now something that was a single box now divided into different units. The RAM that we're talking about, it requires integration testing, certification testing. That is something that ORAN Alliance facilitates, right? And there is a open source community also. You will find this on GitHub. So ORAN software community, and it's basically made a business foundation project now. It consists of some sample standards and implementation. So they basically continue to align with the business foundation and other telecom industry bodies like ATIS and so on. Okay. So this picture just shows how ORAN Alliance projects are aligned with other business foundation projects. And you'll find a lot of information about this on both the ORAN Alliance site as well as the website. So there's a lot of synergy that is now taking place between ORAN Alliance, Linux Foundation and ONF. So they have joined hands and combined. So initially the ONF had these projects going on, the SD-RAN project that implements the ORAN compliant non-real-time radio controller for SD-RAN. We have been moved into Linux Foundation projects. So by the way, from this slide, slowly you will see that how in telecom we have something called as the alphabet soup, right? Lots of acronyms, especially in 5G. When you come to 5G, you see just loads and loads of acronyms. So welcome to my world. Yeah, next. So, so far what we have looked at is what is RAN, why other RAN, and the different industry bodies that have contributed to the demand. Now we will take a closer look at what exactly Open RAN is today in terms of the ORAN Alliance defined reference architecture. So before that, we will also take a look at the components inside the RAN. Okay. So we'll not be walking through each of these blocks, so you don't have to worry about it. I'll just quickly explain. So this is the view of classic RAN, where this entire thing is single node. Now please look at this diagram from right to left for whatever reason. They decide to draw it like this. So this is the antenna where a mobile phone signal will be received, and then you have from the radio signal to conversion, physical layer, media access layer, so on, the radio resource control. So this entire thing is actually a base station, right? A base station on the antenna that we see, and that was like a monolithic thing. Only one node, EOD 4G network. So it's all monolithic. You buy it or don't buy it. You don't have any other choice. So how it is changed by 5G, right? So this is split or open RAN. So now the same functional blocks have been divided into 3 units. First part is radio unit, which does the actual radio transmission and reception, and part of the physical layer from the OSI functionality. Second is the distributed unit, which does media access control layer, radio link control, and bit of that, and then the central unit does the layer 3 part of layer 2 kind of functionality. So radio unit, distribution unit, central unit, and how they actually relate on the network. This is how, right? So you have this radio units typically the actual antenna that you see. The distributed unit will be staying close by, either below the tower or somewhere close by. And multiple control units will be, multiple distributed units will be connected to a single central unit which will control them. Right? So this is a different view here. So we have now left to right, okay? A bit confusing, but there will be. So this user equipment, there is a 3GPP standard, and this is a normal radio link that we have. And where the ORAN or the Open RAN part has come, we have open interfaces. When we say open, meaning different companies will collaborate on those interfaces. So we have open interface between phone and your tower. We have open interfaces between the RAN and the core network to an extent. But within the RAN, the interfaces were not open. Now with Open RAN or RAN advanced standards, this is what we are creating. The interface between the radio unit and distributor unit is open. So you can buy a radio unit from one company which is specializing in radio units, and you can buy a distributor unit or centralized unit from another company. And that another company can be actually, it not be equivalent provider, but someone who is like equipment manufacturers like Dell, HP, IBM, anyone who can basically provide you general purpose hardware which is can be stacked and deployed as a mini data center, right? So that's the advantage here. So that's what we are looking at. Okay. So now a bit about the functionality of units, right? So here is the lower layer is the radio unit. Then there is this interface, the opened up interface between radio and distributed unit. So what do they do is essentially this is the their division in terms of layers. And here we will find some description, right? So this is the main radio unit does real radio stuff, decoding, receiver, coverage, power consumption, all those things. The front-end interface defines the actual requirements in terms of how the data will be transported from the radio unit to the distributed unit and related requirements. And then here, distributed unit does a very important job of actually with the channel coding and defining the resource allocation. I mean, when we talk about resource allocation on the RAM, we are talking about allocating channels and frequencies. Okay. Is that 10 minutes done or only 10 minutes remaining?
It's 10 minutes. Just 10 more minutes? Yeah. If she's showing 10, this means 10 more minutes.
Okay. Alright, so I think I'll go over here. This is 20 and 30 behind. Anyway. Okay, so essentially here this means the functionality is distributed like this. And let's move on. Now this is just to give an idea that even though we have defined the relationship between these three units, there are a number of ways in which the functionality of radio unit can be clubbed either in the radio unit itself or in the distributed unit. So you can see the variation that this block is either here or there, which means it's not exactly standard. So ORAN Alliance has some standard variations. So a standard cannot be very rigid. It has to give some flexibility to the equipment manufacturers. So it does give that, but it tries to define the medium discrete distributed things, right? So essentially what has happened is because of that fragmentation over a period of time, this multiple efforts were there for RAN and overran, and now they have all converged into ORAN, right? So CRAN and VRAN, they were earlier initiatives, but now they have consolidated, so ORAN has basically consolidated into a single standard. Yeah? So this is the reference architecture from ORAN. The important thing in notice here is you have the ORU, there is open RU, open DU, and open CU is also there, divided into two parts. What open ORAN Alliance has done is essentially added this service management orchestration, SMO, and these RICs, radio RAN intelligent controllers. That is the main addition, and these have a pluggable architecture where you can actually have pluggable applications, intelligence applications that will help you optimize the performance of RAN. Right? Yes. So here we quickly see, so this was the original earlier slide that we saw. So these different units have to work on very different timelines. And that is what this slide will tell you that the radio unit part, to execute centralized unit part, they have to work on very stringent requirements less than 10 milliseconds. And then we have this near real-time controller that is going to optimize so these functionalities go to the timeline of less than 1 second. And anything that is more than 1 second, that is in non-real-time analysis, is part of the SMO. And these are the type of use cases that this would handle. And finally, the orchestration, that is SMO, that is more than 1 second. Okay. So these are the benefits that ORAN networks offer: provide interface to plug-in intelligence through apps and intelligent optimization of the resources and possibilities for innovation and standardized interfaces. Yeah, so this is one important thing: standardized interfaces with underlying cloud infrastructure. So when we say ORAN, CU and DU can be hosted on a cloud general purpose hardware, we need to standardize that. So when you have a cloud infrastructure, like you could have a Kubernetes cluster, or you could have some other VM, very likely Kubernetes will exactly those CUs and DU instances to be created, and what would be their spaces there, all that has to be standardized. So that is where this standardized interfaces required by ORAN comes into picture. There is something called as O-Cloud, that's another block that ORAN has. Yeah. Next. Next. So we look at challenges, right? So yeah. So the green ones are actually technical or technological challenges where you can actually explore, like people who are interested in point solutions, and these red ones, integration, releasing, and support are more for business challenges for the mobile service operators. Integration, because our ORAN means we have multiple vendors from where you are getting the solution, you need to integrate it, you need to test it, and mobile network operators don't really want to do that most of the time, right? They hate it. That's the problem. Someone needs to help them. Then there is reskilling. The people in mobile network operator space, they have been familiarized with the box and pipes kind of setup, right? We have switches and connections, and then maintaining them. ORAN will be very different word for them. ORAN will be very different word because it is all software based. So we are talking about controlling everything through, say, Kubernetes console and related tools. So to borrow an analogy from an old article where it talked about internet people and telephone people, bell heads and neck heads, I am terming this as box heads versus pod heads. Box heads being the person who is familiar with network boxes, and pod head is someone who is working familiar with Kubernetes pods, right? So, and then since we're talking about intelligence, we need skills to support AI and ML as well. And then getting support in case something goes wrong in the production network, pinpointing the issue in an open RAN where we have equipment from 5 or 10 vendors would be a problem. So they can get ugly at times. So there has to be some mechanism to address that. Yeah. Next. So security is another big technical challenge, and the reason being number of reasons. Right? So open RAN basically is part of the public network, which will be used by multiple users. So any breach that happens in open RAN software would mean not only the mobile network operator will be impacted, but the privacy of the users who are connected can also affect. For example, location information about the users can be disclosed, and so on. So, and earlier it was very simple that you are buying the entire RAN equipment from one vendor, you hold them responsible, and end of story. Now it's not that simple. When you have multiple vendors that you are getting this equipment from, and you need to make sure that there is no rogue software being injected as a part of this stack. So from multiple people. Yeah. Okay. So this picture, obviously I'm not going to read through this, but this just shows what are the different types of threats because of the open RAN model. So you have a hardware layer, there's a virtualization layer, and there's a software layer, and every layer brings their own set of threats in terms of threat modeling. and the program solutions, the program solutions that we want to provide have to address this. Yeah. Next. So ORAN has this work around to help you with the challenges. They have this certification that you need to look about. The WG11 is a security group from ORAN, and they do these inputs to come across the challenge. Yeah. Next. So we look at this, right? What are the opportunities, right? We can develop innovative applications using OpenRAN and AI applications, and the other opportunity that I see for people is to improve it to basically contribute to OpenRAN development, open source project themselves. That's what we do. Really interesting. Yeah. Next. So from a technology point of view, these are some interesting technologies that you will need to work on and you can explore. And I would request students to note this down. Maybe this will help you down the line to connect the dots and see if you want to look into that. Right? Kubernetes is the basic thing that you'll have to do this because all everything is moving into a cloud native and container-based solution. So that is a, as I call it, table stakes. Then software-defined networking, what it does, separation of control plane, user plane, what exactly is. ONOS is a good controller from ONF, something that you should look at. And we have an NFV, network function virtualization. More, this is actually softwareization that has been talked about and moving from hardware to software. YAN, network, GMI, GMR, these are all configuration management tools that allow the SDN controllers to talk to individual network functions to configure it. Okay? Next. So these are very special kernel level technologies. These are open source technologies. You will find the details here. If you are going to write a network function that will be part of like a C or D, right? Then you need to understand these technologies because these technologies make data plane processing faster in custom general purpose hardware. So to complete the custom hardware, general purpose hardware to use these technologies. So these are something that you definitely want to note down and explore further, and you will contribute to these things. Yeah. Next. So these are the open source projects that you can note down on the president, and I would like to specially mention the NPO, a lot of activity happening there. It's a kind of a Kubernetes to be used for network operation automation, right? Very exciting thing that's happening going on. LS Anuket is also related. So you'll see each details in the slide deck. You can go through this. You can get the links for this project very easily. But these are very important projects from open hands point of view. Someone who wants to work in this area. Yeah. Next. So market dynamics, right? A lot of activities, and what is happening is essentially since the open hands are getting software, the network function is getting softwareized. A lot of new entrants are coming in, as I mentioned. Hardware vendors, cloud providers themselves. So you are going to see that if you want to work for mobile network, your telecommunications is your interest, and you also want to work for Google, that's very possible because Google is actually offering a 5G service entirely hosted on that cloud and many other things as well. And there are a lot of collaborations happening in this space. So there are niche and new players also focus on 5G. Like this, right? These are some of the things. So yeah, that's actually it. I would like to summarize that. Any questions? Do I have time for questions in case anything?
Guys, if you have any questions, just raise your hands and we will bring the microphone to you.
Okay, thanks everyone.
Okay, so thank you everyone for your participation in questions. It has been great pleasure having Santosh Sapreshi with us today. We are grateful for your time and knowledge you have shared with us. So let's give a huge round of applause to him once again.
Mic कर. माइक का वो लेके गए क्या?
नहीं रखा है।
उनको जाओ माइक ले जल्दी।
नहीं रख दिया था उन्होंने, रख दिया था टेबल पे रखा है श्रेया।
नहीं रखा।
अच्छा
कॉलर वाला
कॉलर वाला रखा।
अब उसको बोल उनको सुनाई देगा। उसको बोलेगा तुम
Hi.
जस्ट 1 मिनट।
Yep.
फ्लाइट से था।
So now it's my great pleasure to
Do you want to share any slides or presentation?
Yeah. Uh, will you be sharing, or like should I share from my side?
If you could send us, we could share, or you could do it as well. You
Okay.
can just share your screen.
Yeah.
Start कर। 2 मिनट बोल।
You are able to see my screen, right?
Are you sharing your screen?
Yeah. Is it visible?
Yeah, check. Yeah.
Yeah. It's just the slides, right? Not the browser.
So
You're seeing the slides, right?
sorry.
You're seeing the slides, right? And not the browser.
Yeah, we're able to see.
Yeah. Cool.
So now it's my great pleasure to introduce our next speaker for today, Mr. Deepak Patangar. He says, I am an open rating contributor from 2018 and I have been mentoring GSOC students from 2019. My contributions to the printing ecosystem includes allowing support for auto clustering arbitrary printers. So without further ado, let's welcome Dr. Deepak Patangar on stage. So please join me in giving him a huge round of applause, everyone.
Hi, everyone. Thanks everyone for joining. So I'll be presenting a small breakout session for 15 to 20 minutes on my journey of open source as a contributor, then as a mentor, and I'll present how you can contribute to various programs and what are the perks of joining open source. Yeah, so my journey started in 2018 as a contributor. So usually Avik, who is the who handles Linux Foundation, sends email to most of the IITs uh, to get people involved with, in open source. So I also got an email somewhere in November and December, and I approached him for the projects. So the journey usually involves working on a small task or fixing some small bugs in the system. Once you've fixed all those bugs, you can start selecting the project of your choice, and then you have to prepare a document like proposal for the project. And when GSOC starts, eventually in summer, you can start your project and start contributing. So my project was enabling auto clustering support in printers. This was something which was not being present there. So it was quite an interesting project to figure out how to design, how to implement this project. And eventually I turned out to write 10K plus lines of code uh, to support this project. And being in third year, it was quite a happy feeling. So it quite a confidence that if I'm able to write this much amount of code, uh, and it's going live and on every system. It's a big achievement for me. So yeah, that's how my journey began as a contributor. Yeah, just to show, like, just to discuss what all I learned while in the initial uh, phase of my project. So mostly, like, since I'm part of open printing, it involved a lot of printing. Like, I fixed some things and printed, so it was quite fun. But from a technical point of view, my learnings were as follows. So the first one was about Linux work. Uh, so I learned about all the Linux commands, how various systems and softwares are written in Linux, and how those components interact with each other. So even this was very useful for my third year OS course because I was able to apply whatever I learned while doing open printing. Uh, the second important thing which I learned is how to work on something from scratch. So, like, if you're working in a job somewhere, then you'll be working on front end, back end, or ML stuff, which are like, there are frameworks for those. There are tools or there are blogs written for those. Like, you can just refer to blogs like how these things are done. But for open source, it's quite different. Like, you're working on some problems which are not yet solved, and you'll have to read a lot of documentation. You have to communicate with a lot of other other like open source community members to figure out how to solve the problem. So as a contributor, it's a great learning to work on something from scratch, like design it, develop software without using anything which is already available. So, like, for example, in open printing, we were currently working on adding scanning support to Linux systems. So we are able to print something from Linux system by default, but the scanning support is not there. So you can realize that it is very different from the web development or anything we do, uh, because now you have to see how internally you will communicate with scanners, all these protocols you have to discuss and figure out. So uh, it's a great learning to see more internal computer science part of it than compared to job. So the third thing which I learned is reading huge amount of documentation. So since we are building something new, a lot of things are very properly documented in open source. Like, what are the protocols, what are conventions which are being followed. So while designing, we have to read all those big documents and implement the solutions. So that's a good learning in itself. Uh, yeah, then I moved to a mentor. From 2019 to 2024, I have been a mentor, and being a mentor is a different journey itself. And there were a lot of good things which I learned. So first was designing solution. Since I'm part of open source from let's say last 5 years, I have a good amount of context how to design solutions. Like, also a good amount of context required on the system itself, like where the code is, what are the conventions, what are the protocols to follow. So I have been helping my mentees design solutions uh, from scratch, and this has been a good learning for me also to see how various components in open source interact. Second learning for me was breaking projects into smaller parts. Uh, so a lot of tasks in open source are uncertain. So we have to break down into small chunks which are executive and are more certain. Like this, if we figure out this part, then we can move to the next part, and then we'll figure out the next part. So this has been a good learning for me to break projects into smaller parts. The third learning, which was I think mostly on focus on long-term impact. So GSOC is like, let's say GSOC or other open source projects. It's not just about completing the project in the timeline. It's more about equipping the mentees with skills which are required to contribute to open source, which are like writing clean code, contributing to documentation, or being an active member of the community. So, like being a mentor or being a mentee, you will get to learn a lot from technical side, from product management side. So, like I would recommend, like you can start contributing to any projects which you like. So, moving to the interesting part, what are the perks of joining GSOC or any open source community? So, the first one being, whenever you're applying for jobs, uh, preference is given to person who has more open source contribution. So, like currently I'm in Amsterdam and I've seen abroad it is like people consider open source contributions very variable, and it is very easier for you to get a job of your choice if you open source contributions. So I have seen people who has open source repositories of front end components and other things, and it was very easier for them to get a front end role in any company because they were the top contributors for a very important component. So yeah, the first perk is if you will be given preference. The second perk is a feel good like perk where your code will be part of all the Linux system in the world, and it will be used by millions of users. So it's quite a good feeling whenever your code get released, and you know that now everyone on the Ubuntu system will be using my code. Third one, of course, goodies. You get a lot of goodies from your organization. The fourth perk is you get mentored by top contributors. So all those maintainers of the open source communities are people who have been working in this particular area from quite some years, and you get to directly interact with them to work together on some projects. So my mentor was Steele. He's a Linux fellow, and yeah, I'm grateful that I got to work with him. So there are other projects too, and you will get the top contributors to work with you. The next perk is stipend. So there are some projects which pays a quite good amount of money, and you can join those projects and also do open source. Next perk is referral from Google. So if you are applying for GSOC, you also get a referral from Google, and you can redeem it anytime whenever you want to apply in Google. Next perk is attending conferences. So as I've seen, like mostly the open source people get to attend conferences. If you're doing a job or something, it is very rare that you'll be going to some conference or you'll be going to a very specific conference. But if you're part of open source, it opens a lot of opportunity for you to attend various conferences, learn about various stuff, which is quite new. And the last important perk is like you get to enhance your technical skill. You get to learn about the open source world, and also like whatever projects you're working on, it will enhance your technical skills. So overall, I think being a part of open source is quite beneficial, and it has a lot of perks. So I would recommend, like, if you can contribute to some project or you can take part in any of the open source programs, you should try to. Yeah, regarding conferences, I also got the opportunity to attend few of the conferences. One of those were like Ubuntu conference in Prague. Yeah, it was quite nice because I saw all those people who are maintaining and managing Ubuntu. I got to see how the company is earning, how I got to see what are new things they are doing in the Ubuntu world. So like in college, I was using Ubuntu from first year. So it was quite good to see like who is working on Ubuntu. And of course, with conferences, you get to travel a lot. So that's a big perk. The next conference which I got to attend is the SOC Mentor Summit in San Francisco. So if you're a mentor, you'll get an opportunity to go to Mentor Summit, which happens every year in Google's office in SF. and it's also quite nice. There are a lot of contributors from various open source organizations which are there, and they will be presenting their projects. Also, their projects are quite interesting in the domain of there's some Python libraries, just special databases in ML, AI also. So if you plan to become a mentor, you'll get the opportunity to go to these conferences and present your work, get to know what other people are doing. Yeah, so that's mostly about the conferences. Moving to the most important part, like how you can contribute. So the first way is to contribute to open source programs. So you can apply in Google Summer of Code or similar projects, advertise a list of similar projects. Uh, you can, if you're applying to these programs are more systematic, and you'll be assigned a project, you'll be assigned issues, mentors, and all. So, and also stipend. So it's, if you want to just start, uh, preferably you can try open source programs first. The other way to contribute is to contribute to projects of your choice. So a lot of projects are open source, or you can start your own project also. And you can contribute based on the skills, the interest you have. So even if you want to contribute to web development, there are some good projects where people are building React components, Flutter packages, and all. So if you want to, there are a lot of options available in whichever area you want to contribute. I'm also touching a list of beginner-friendly projects. So these are like projects which have some beginner-friendly tasks. There are projects like TensorFlow and other projects also. So you can just pick up a beginner-friendly task and contribute and start contributing. The other way is like there are some projects which are abandoned, as in like the maintainer wants to move on to a new project. And if you want to be a maintainer for important project, you can start maintaining it and take the ownership of the project. So this way you have a big project of your own. So yeah, that's all about how you can contribute and make an impact in the open source world. Yeah, that's all I have. So mostly I hope you find it interesting to see like how open source can help you build your skills, and hopefully you find some projects of your interest too.
Okay, guys, if you have any questions, just raise your hands. We'll bring the mic to you. Okay, so thank you, Mr. Deepak Patnaik, and thank you all for your participation. It has been a great pleasure having Mr. Deepak Patnaik with us. We are grateful for the time and knowledge you have shared with us. Let's give him another round of applause.
Thanks everyone for joining. See you.
Thank you, Deepak. So,
good afternoon, everyone. I hope you are all having a great day. My name is Kanish, and I'm honored to be your host for the upcoming session. Thank you all for joining us, and I'm sure it will be both insightful and inspiring for everyone out here. Now it's my great pleasure to introduce our next speaker for today. His name is Vlad Gold. Vlad is a networking engineer with a security background most known for his contribution to the censorship circumvention scene, long-term Linux user and AHL software developer on occasion. So without further ado, let's give that girl on stage. Please join me in giving him a warm round of applause, everyone.
All right. Hello, everyone. I would like to tell you about my little project, a print server, a print device, which is intended for the older printers.
If you want to get the change, I will change it from here. See you next.
So, a little bit about me. My name is Vlad, and I go with the nickname Valdis or just Val. I use Linux since 2008. First, my distro was Mantriva Linux, then I used Ubuntu for Mineware, and now I'm a Fedora user. I used to work at the security scene, so I was doing the security audits, pen tests, and reverse engineering of some banking proprietary software during my work. But nowadays, I more of a censorship researcher and research like the government internet blockings, how do they do in different countries, what are the particulars, and develop anti-censorship software to circumvent such kind of blocks. And I also an amateur software developer. When there is no one wants to make the software for me, I have to do it myself. So I don't own a printer, and I never owned a printer in my life, but on occasion you need to print something. Like it happens 5 times a year, you need some kind of document for the government or some kind of just paper, information printed out. And it's very inconvenient to go somewhere because sometimes it happens at night, sometimes you need it working. Or just like on Saturday or Sunday. So I decided, why don't I buy finally my own printer? And the interesting thing is that the older printers are the more reliable, the more robust one, because the 2002 and till 2007 or 8 was like the top peak of laser printers. And if you are looking for a model, it would be more reasonable to buy a used one printer because they are built to last. You can easily refill it, and they don't have the chips on the cartridges, which prevent you from reusing the existing cartridge. The modern printers are forcing you to buy a new cartridge from the original supplier or to hack the printer. But the older ones don't have such protection, so you can refill it easily for cheap, and the printers are built to last, so they just don't break as easily as the modern ones. But my model, which I bought for very cheap, is a model from year 2002, Canon LBP 1120, is an obsolete model. It doesn't have support for 64-bit drivers, and that's the main reason why it is sold for cheap. You can use it with the modern version on Windows, because Windows drivers are not compatible between 32 bits and 64 bits operating systems. But it is supported in Linux. And I thought, well, how will I connect it? How will it use in a modern operating system? So apparently I need a print server. This is a kind of device, a kind of box where you connect your printer using the USB connection, and it shares your printer over the network using the Ethernet cable or just over the Wi-Fi. And these are some models which you can buy. They are pretty expensive. I didn't even know that such devices are not so cheap, and you don't know how do they work. Do they support my printer? Can I use it to print from my phone? So let's figure it out. It seems this kind of devices, so-called dumb print servers, they are just a port forwarding devices. You put in your printer and they just share your USB connection over the network. So they don't maintain drivers, they rarely support scanning feature, and they still require you to install the driver on the PC or on the smartphone. You can't use it from the smartphone in my case because there is no driver from the manufacturer. And you need to manually configure it every time on every computer, like enter the IP address of the device. This is just not convenient. These kind of devices are old. The technology haven't improved since 2000s, and this is not what the user wants. So I also checked the compatibility list, and for some reason, my exact model is not supported on every device which released there. So even if I want to use this simple device, apparently I cannot use it. Let's take a look on how the modern printer work. What's the difference between the modern printers and the older ones? Why the modern models allow you to print from the smartphone and are easy to install, but the older ones require drivers and software stuff. So the technology took a pretty big leap. The printing technology has standardized everything. Nowadays there is a universal printing protocol which is based on HTTP, universal formats of the data you send to the printer, and raster data or just a PDF file, and it's universally supported everywhere on the Android, on iOS, and on desktop operating systems. There are two major standards. One is Apple AirPrint, which may be familiar to the iOS and macOS users, and Mobile, which is supported on Windows and Android, and Linux supports both. These formats are pretty interchangeable. They are similar in 99% of time, and if you see the printer which specifies that it supports AirPrint, it most probably supports Mobile too, and vice versa. So I thought, if I can retail device, a retail print server, can I make the one myself, which will fulfill my needs, and what do I need for it? And the answer is yes, yes, of course you can build such a device. And everything is already finished for it from the software stack. There is a Linux print server, server software called CAPS. You probably heard a lot of it on this conference, and it already out of the box supports sharing the printers using these protocols like AirPrint and Mobile. So you just connect your printer. If you have a Linux box, you can check the checkbox, share my printer, and it would be discoverable on the smartphones and on other computers in your network. There is also a scanning server. This is also software for Linux. It allows you to scan from the dedicated scanner or from the multi-purpose device, which combines printer and scanner. But it doesn't support the sharing. Although there is a separate software called AirSafe, which basically combines the same scanning server and sharing it over the network. And obviously, oh, great. Yes, and of course it's all running on the Linux. You can run it on a dedicated machine, on a dedicated server, or you can use something simpler like a Raspberry Pi or something similar, small board with an ARM processor. Obviously, similar track. So what do we have about the hardware? From the hardware side, I found this pretty capable board. You can use basically anything, but this exact board has 256 megabytes of RAM, which is quite sufficient, but not enough. But with some cards, it's totally fine for home use. It supports 512 NAND flash memory, which is pretty a lot for a simple, for minimal Linux image. It of course have a USB port for you to connect to your printer. It has a Wi-Fi connectivity, and this particular board has a lot of extra features like the audio, the built-in microphone directly on the PCB, the display and camera connections, and also the 3G connectivity. You can insert your SIM card and connect to the internet directly from the board. And what's most important, it is only $8.
Next slide. Yeah.
So how could it be so cheap? Why $8? This is ridiculous, right? Like the Raspberry Pi it starts from $25 and the other board could cost like 40, 50 bucks or more. Well, the answer is there is no working software. Like the board is barely working. The device manufacturer didn't bother to prepare the operating system image, and it's just like a very minimal image which don't have much features. The log is flooded with the debug messages. You can log in, you can do anything. That's why these boards are just don't sell well, and they are forced to decrease the price over time. And now they sell it for only $8. So that's a great opportunity. Can we reuse it? Can we develop a proper software, a proper operating system for it, and use it for our own good for a very cheap price? Next slide, please. So I thought, am I the only one with this problem, or is there any other people who want to have the same preserve, the same convenience as the open source software provides? So I made a poll in Twitter, like, do you want this kind of device? I'm going to make a mini product. So will you buy it? And there are 93 voters who checked that yes, I'll buy such device if it exists. So I thought, okay, let's go from DIY space to some kind of small-scale retail space. What do they need to make it? First of all, it's the features. Like this is a commodity device. This is an appliance tool, and people see it as a device, not as a piece of software. So it should be easily configurable. It should come with the web interface, and the device itself couldn't be sold like as just a board. It should come with at least some kind of case. So I made a small casing with just two acrylic glass pieces. And well, it's very cheap and it prevents the user from damaging the hardware, from short circuiting something on the board. And the web interface is clear and straightforward. It allows you just to enter your Wi-Fi credentials, change some options, and well, that's it. I said that your mom should configure it without your help. The device should be as simple and as easy, as straightforward that the non-technical user should be able to understand how does it work and how it should be used. And of course, it should fulfill the user needs, so it should bundle all the needed software, all the needed drivers, even the proprietary ones, and it should just work out of the box. What about the operating system? Well, since this is a hardware device and user sees it as a hardware device, it shouldn't lose any configuration. It should sustain the power loss, and it should boot automatically after the power loss. It shouldn't lose any configuration, and it should support factory resets. This is done by using the read-only root file system, and the configuration is ensured to be synced every time it's changed. So even if you cut off the power just after the same configuration, it will be the same as you expect, and the device will be in the same state as you expect. About the security, the device shouldn't introduce any security holes in your network, right? And with the availability of IPv6 network, it's more than issue than it was with IPv4. So it should come with pre-configured firewall, which will restrict the incoming connections from the outside, from the internet, and isolated only inside the local networks. The device doesn't have any built-in hard-coded password or anything. Everything is unique for each item, for each device, and you can reuse the password if you know it from one device to another one. So it's mostly compliant with the standard of IoT devices security in terms of network connectivity, firmware updates, and so on. And of course, we should think about customers. How should we advertise this kind of device? The user don't know much about software. If they know about software and they can DIY their own device, they don't need marketing, right? So we should answer just a real simple plain question. How do I print from my old printer using the smartphone? How do I connect my old USB printer to the network? And you should answer on these questions by providing like the solution. You don't need some technical details. And also, several months ago, the new ARM machines on Windows have released like on ARM Snapdragon processor, and some printer manufacturers don't provide ARM drivers yet, or they are not planning to provide it at all, because, well, it requires compilation, it requires this and that, and they have a new series on the old printers. They want to sell newer printers and don't want to maintain the old ones. So this kind of device, since it's driverless, it also allows you to print on ARM-based machines. The operating system is based on Debian 12 because it's easy to customize and the image is pretty minimal. It's built in Linux with the help of NKOC utility. If you are familiar with Docker build, it's pretty similar, but it is built particularly for the operating system image. It can produce a virtual machine image, it can produce like a container image, and in this particular case, it builds an UEFS system image. It is very simple and it doesn't require any additional software, it runs on any distribution, so it's quite convenient. And all the additional software, all the proprietary drivers are packaged in a separate dev packages to simplify the management and version control. And you need only 4 steps to build the whole firmware. And also generates the bill of materials, like the list of the used software versions, so you can track the versions in each firmware version to check are there any new discovered vulnerabilities, and if there are, which version is not vulnerable and which is vulnerable. Just by simple rebuilding the firmware image, you can update the packages, flash it on your device, and use the protected versions, updated versions of the packages. Next slide, please. So let's talk about how does this project influence the open source space. Next slide, please. Since we are using open source software, it is safe to contribute back because it is just simpler. Everyone could benefit from the patches, from the fixes found during the development, and it's just easier to use the upstream software because you don't have to maintain your own patches upon the original software, and well, it's a win-win situation. Since I sell this kind of devices to the end user, I'm forced to solve the issues. So I have to debug some configuration issues, some deficiencies in the user software, and since I have to fix it, I'll contribute it back anyways. And all this kind of increased attention from non-technical users and from broader range of printers leads to just better software. Next slide, please. And let's talk about financial contributions. You know, the whole project idea was just to create a pool of money for the open source projects and to contribute them financially from each sold device. Most of the time, open source software developers don't receive any donations, any financial contributions, and I thought that's a good opportunity to combine the software and sell it in the form of appliance, in the form of hardware, and fund do some kind of donations to the projects which this device is originates upon. So from each sold device, $2 go to apps, $2 go to save, $2 go to their save, and additional $2 are left for the future improvements of open source drivers already existing, and for the development of new ones, like for the printers which have only proprietary driver right now. Next slide, please. So what are the goals? All devices are sold out. It seems that my users need this kind of device. They need a convenience. They are ready to pay for convenience. And all devices have been sold out, all 125 pieces of these $8 orange pies. That's all they have in stock. They don't have it anymore. So it's their bad hardware is used for a good purpose. My printer is working with this hardware, of course. That was the whole reason to make it, and I also managed to write an open source driver for it, but right now it works only for A4 paper format, so it needs some development, but well, it works. And users are happy and ask for an additional patch, which would be based on some kind of another hardware, which is more capable, but unfortunately more expensive. You can't find such good deals every time. Next slide, please. My takeaway is that people really need this kind of convenience. The demand is real, and if advertised correctly, they are ready to improve their convenience and not to change their old printers to a new ones. So you use your existing good hardware, which is very cheap to maintain, with all the benefits you have with the regular new printer. And this kind of opportunity is pretty interesting because I haven't heard of any of it. The synergy of open source software development funded by the hardware which use this, which uses software. This creates a broader range of users. It's not limited only to Linux users, but also to any operating system or smartphone users. Some people don't even have computers at home anymore. They have only smartphone, but they still need to print something on occasion. And somebody needs to debug the issues because users are maybe not technically aware, but they have some issue. They can even formulate and understand what is the problem. The printer doesn't print or some option doesn't work. There is need to be someone to at least debug the issue, to understand what is the issue, to file the bug record, or to act to fix this issue. And this kind of hardware also helps in this kind of synergy because, well, it opens the opportunity for the broader range of users. Next slide, please. That's basically all, but if we have some time, we probably have not. I have some extra slides. I'm open to the questions. You can find me anywhere. You can ask the questions if you have some time, or you can find me later somewhere.
Please, if you have any questions, just raise your hands.
I have two questions. Will it also work with my matrix reader printer from 80s if I bought LPT to USB like connector?
Oh yeah, actually it will. You can plug in not only the printer directly, but you can plug in the converter from USB to LPT and then connect your matrix printer or just an older laser printer with only an LPT port. It also supports not only like this kind of extra feature, it also supports the LAN connectivity. You can plug in the LAN card to the USB port using the USB hub and also connect not only using Wi-Fi but also the Ethernet cable.
So we can use printer that worked on pure Unix before.
Yeah, we can use matrix printers on Windows 11 like the printers from the 80s and it will print just fine.
Can we run this program on really important things like ESP32? can be slow, of course, but the main thing I think it's not much memory, but the speed of the two have USB, as I understand, have wireless, and there's two key things that we need to run the print server.
So the question is, could we run such a print server even over smaller hardware on a microcontroller? Unfortunately, it's usually not enough memory for processing of the documents, and you need memory to convert universal format to the format that all the printer understands. And it's also all about drivers. If we are talking about proprietary drivers or even the open source one, we need to port it to the microcontroller operating system. And sometimes it's possible, yes. But this kind of small older print servers, which I mentioned in the beginning of the talk, are basically the microcontrollers. Yes, they are working on the same principle, but for some reason they are very expensive.
So they're a little better than the box because they're small.
Yeah. Okay.
Yeah, that makes me wonder if it's possible to connect the printer to the Wi-Fi router. Is it also
You mean the microcontroller which have...
just plugging?
Well, yes, this is exactly what my print server does. If you have a Wi-Fi connectivity, you can connect it either to the existing network or it would bring up the access point, just scan the QR code from this sticker and connect it and print it.
Modern Wi-Fi routers
Погоди.
can run.
So if I have a board at home, I think the code for that, can I run it on my board too? If I have a Raspberry Pi or any single board, what is it?
Oh yeah. Like right now, my operating system is a bit tied to the board. I use like the handle of the button, of the physical button of the board, and some Wi-Fi pieces like the firmware for the Wi-Fi model. But in general, yes, it's pretty easy to work on any other board, and I'm planning to build a container. So if you have any regular operating system on your single board computer already, you can run Docker or anything which supports containers and just run the whole stack, the whole proprietary drivers already packaged in a single container.
Okay, but if I get the same board, so I can flash yours onto that board too.
Yeah. The main also I didn't mention that sometimes you have clones of hardware, right? So I decided to supply the firmware and firmware source code only to the buyers of the board, but I'm thinking on this decision and planning to make it open source, widely available somewhere. But yes, it's possible to install it on any board, not only on ARM board, but potentially on the other architectures like x5 or just on x86. All right. Thanks, anyone.
Thanks, Mr.
Do we have lunch right now or some?
Yeah, it is.
So when we can end our streaming, because we start another streaming after lunch.
So, guys, we are having a lunch break now. You all can have your lunch at Doha canteen or any of the hall